Hey guys, so today we're going to do average rate of change. Hopefully those words right there sound familiar because we might have done it this way before. But average rate of change we've also known, like think of this, the rate, right? What does that remind us of? Well, hopefully you're saying, well, that kind of reminds me of what we call slope. So the idea with slope, right? Slope is the average rate of change of a linear function. The linear, it is slope because it's a constant slope between any 2 points possible, right? But when we talk about other functions, which is a lot of stuff that we're doing this year, right? We don't call it slope. We call it average rate of change because we're saying from this point to this point in the graph, this is about what the slope or the difference might be. So if we were to connect that with slope, let's talk about what slope was. Slope was rise over run, or what we call the change in y over the change in x. So one of the biggest mistakes people make is that they put x over y. Okay, so right here. So what we're going to do is we're going to do the change of our y values over the change of our x values. And that's what we call the average rate of change. Now, the line that connects these 2 points that we are finding this slope for is what we call the secant line. So we're finding the slope of that secant line. Secant lines cross through 2 points. So example 1, if we were asked to find the average rate of change for this function on the interval -3, 5, we have to keep in mind that this interval here is our x values. Okay, so anytime you are getting an interval like this, these are the x values. So of course, when finding the average rate of change, we need y's and x's. Well, if we have x's, how can we find the y's? Well, we can find the y's by plugging it into the function. So I'm going to plug in -3 into our function. -3 plus 3. Well, let me write this out so that way you can see it actually being done, and then you can go from there. So I'm going to plug in the -3 into the x. And what do you know? -3 plus 3 is 0. The cube root of 0 is 0. 0 times 2 is 0. Now we're going to do the same thing for 5. We're going to plug in the 5. So we have 2 times the cube root of 5 plus 3. If you have to use a calculator, go for it. So 5 plus 3 is 8. The cube root of 8 is 2. 2 times 2 is 4. Okay. Now that we have our x and y values, now we're going to put it in the average rate of change equation. So when you deal with y1 and y2, it doesn't matter which one's which, as long as the x and the y match up. So in other words, if I didn't, because I have to do my y's. So remember, my y's are 0 and 4. So if I said 0 minus 4, because those are my y's, all over. Well, if I put 0 first here, I must put that x with that coordinate, which is -3. So this is another mistake students make, is they will switch your x1, y1 stuff, and then your answer comes out to be the opposite. All right, and then we're going to calculate this. So 0 minus 4 is -4. -3 minus 5 is -8. And then let's simplify that even more to 1/2. So the average rate of change between these x values for this function is 1/2. Okay. Now, there are other ways that we can do our average rate of change. So when you have a function, if you forget, come back to this example. This is about our functions, starting with the function in an interval. Where on our next one here, what we're going to do is we're going to use our table. But with this also, I want to keep in mind that this is a scenario. So when you are done, you need to write a sentence on what it means to this scenario, okay? So a couple things to keep in mind. What are you talking about? on average, increase, decrease, how much, how often, when. This allows you to make a great sentence when it comes to your answer. So first, let's actually do the average rate, and then we'll write our statement. The table shows the U.S. farm exports in billions for several years. Find the average amount per year from 1996 to 2000. So usually when it comes to a table, I like going and making sure I circle what coordinates I'm using. And it says 2000, but I don't see 2000 on here. Oh, it's on the other side. Sorry, guys. There we go. Okay, so I circled those two. I'm gonna have to flip back and forth, sorry. Okay, again, it doesn't matter what order of the y's that you put it in, as long as your x's are the same. So y values, my years is my x value, my amount is my y value. So keep that in mind. So I have 60.4 minus our second y value. Let me flip the page. 51.6. Okay, all over x values. Now, if I use 60.4 first here, I need to use 1996 here. And then minus, and then we were talking about 2000. Okay, so this is our average rate. So let's actually put that together now. Now, in this case, I might use my calculator because I want to make sure that I'm not having a decimal within a fraction. I want that simplified. So I'm going to do parentheses 60.4 minus 51.6, close parentheses, divided by parentheses 1996 minus 2000. And put it back into a fraction because we're going to talk about making a sentence, right? So go math, enter, enter. So we get a negative 11 over 5. So now we're going to write a sentence and interpret what this means, okay? So what we're going to say is the average let's see, we're talking about exports, farm exports. Are, so maybe instead of saying the average, say on average. On average, farm exports are, now this is negative. So you don't want to say are negative. You want to say are decreasing. So if it was positive, we would say increasing. Are decreasing. Now let's interpret those numbers. 11 means 11 billion. Over, let's see, on average, exports are decreasing 11 billion over 5. And what does the 5 mean? The 5 means years. You could say over 5 years or every 5 years. So it's decreasing 11 billion over 5 years or continuing every 5 years, okay? So see how I'm saying on average, I'm relating back to the situation. I'm saying if it's increasing or decreasing based on the positive, negative, and I'm explaining what each of these numbers mean. 11 means billion for the exports and 5 means years. All right, so that was, we did our function, we did our table, and of course, our next one that we could run into are our graphs. And this, yes, it's a graph, which is nice, but it is also a situation. So we want to make sure that we're doing that sentence. Jane is visiting London and took a ride on the London Eye. Her distance in meters from the ground at any given time is shown on the graph below. Find the average rate of change from 6 to 21 minutes. So right here we have our coordinate, right? So let's actually look at this. So our y value, remember our y value is right here. So we could say 60 minus, and let's interpret that as 90 all over. And then our x values, well, with the 60 is 6. With the 90, okay, that's in between. So what is that? That is 22. Let me check. Or is that 20? 21. 21 is in between there, which makes sense because we're going to 21 minutes. I could have got that answer right from there. All right, let's see. That would be negative 30 over negative 15, which gives us a positive 2. So when we write our sentences, we say, on average, Jane's distance, sorry guys, my light went out, distance from the ground is, now let's interpret. The 2 is actually in the numerator, right? This is 2 over 1, and is positive, is increasing to what? 2 meters every, and then what would that 1 mean? Well, every 1 minute. Now I know, and when you think of a Ferris wheel and stuff, you think, wait a second, we're not always increasing, sometimes we're decreasing, but remember that we're only talking about between 6 and 24 minutes. So sometimes in your sentence, you might want to refer back to that interval, and that would even make it more exact in explaining and interpreting your situation. All right, that's it. It's average rate of change, practicing with functions, just plugging in. So don't forget, you have to plug in for your y values. We have finding the average rate of change from a table. Luckily, a table is going to have x and y values. And then from a graph. So right here, of course, like it is printed that you have that line there. So you can always go rise over run. Or if that line even wasn't there, you could just interpret that coordinate and put it into your equation. All right.